What could stop IoT? Nah, there's no stopping. The train has left the station.
We will have over 50 billion connected devices generating over 50 trillion gigabytes of data. It completely transforms what the businesses can do.
You could easily have 10 connections per person. Your car, your smart meters, consumer electronics devices, they could all be connected.
It's kind of the solution du jour. Well, it's IoT, let's just IoTify that device and then we'll be fine. We can solve your problem with IoT. IoT is so complex. It takes into account so many different types of devices, so many vertical markets, so many use cases, so many applications.
If it was easy, everybody would be doing it. We'd be racing towards 50 billion already.
The concerns about connectivity, the concerns about cybersecurity, the concerns about privacy are just going to increase in scale, they're going to increase in scope, and most importantly, the stakes are going to be so much higher.
I think a lot of companies have accidentally bet lives on security. Not all, but most devices coming to market are almost completely absent of security.
That's why I call it the Internet of Broken Things. If those things are attacked, it could be life and death.
Initially, it's about this is cool. But cool doesn't pay for 20,000 units to be installed with hardware. IoT will go where the ROI can be made.
You know the old saying, knowledge is power. Actually, knowledge is profit. And if you don't take advantage of this, you're going to be left behind.
We live in historic times, driven by innovation. But is technology providing real value? And how do we translate that value into our lives, our companies, our network? How do we stay connected without draining vital resources? Are we moving towards efficiency and sustainability? Or are we weakening the network? A connected world is what we strive for. It changes the world we live in every day, every minute, and sometimes every second. It's what makes our lives better. It's the network of the future. Inside nearly everything and everyone on Earth is the potential for connectivity. We rest that potential on the devices we build to communicate with you, with your office, with your family, with your customers. We are only just scratching the surface. The dream is a world where we have intelligently connected nearly everything around us. Connected in such a way that we get great value from things we used to take for granted. This is the dream of the Internet of Things.
Back in, I would say 1991, Mark Weiser at Xerox PARC had this vision of ubiquitous computing. And his idea was that technology should just sort of hide into the landscape of things. So we don't really know that technology exists, but it just does things for us.
That vision was well ahead of its time. And while technology was not yet ready to deliver a truly interconnected world, modern IoT began with a simple connection between two machines, albeit one that was very specific and limited.
As the market matured, it went from an engineering community and narrow use case setting to a kind of a medium use case setting, which would be probably the definition of M2M in my opinion, and then ultimately IoT, which I think is expansive enough to cover the real broad landscape of all the different use cases possible.
M2M traditionally was B2B enterprise, and then changing it to IoT really came from the change of adding more consumable over the internet things communicating back to mobile or your computer device.
In this world of internet and also IoT, we will have over 50 billion connected devices generating over 50 trillion gigabytes of data.
The Internet of Things, at its core, is just simply an increase of scale and scope for connectivity and computational power into not just simply more devices, but smaller devices and devices that never had connectivity before.
So what does it take to get connectivity everywhere?
The turning point is companies starting to realize that the margin in devices has shrunk so much, and it is really about services.
The cost of making sensors went down. We have some print electronics capabilities. So now we can make more, flatter, thinner, different sensors that we can spread out into more places.
These devices, when they exist in isolation, there's not much value to it. But when you can connect them all together and make them do things together, then there's a new value proposition.
It's usually an executive that has now found an article in Fortune magazine and says, oh, this Internet of Things can really help our business. And then they're pushing it down to the CIO, who then is pushing it down to the IT department to say, hey, figure this out.
It's kind of the solution du jour. Well, it's IoT, let's just IoTify that device and then we'll be fine. We can solve your problem with IoT.
As IoT gains momentum, solutions begin to be deployed, but the growth is slower than the hype. Why?
There's actually a tremendous number of pieces that you need to have in place to have a successful IoT solution. There's a hardware piece, there's a software piece, you need to have the right platform in place, you need to have the right analytics solution to really make it all work. And that complexity is what makes it a little bit daunting, I think, and that's why we've seen lower uptake. Initially it started with M2M, so everything was going to be M2M. We're going to have cellular modules and all this stuff, and it was all going to be machine to machine. Well, machine to machine grew very, very slowly because a lot of the markets they were targeting, they didn't understand. And so they were trying to go in with a Cadillac solution when all that was really needed was a Ford Pinto.
The early deployments tend to be much more around specific products rather than taking that entire IoT architecture and embedding it. A lot of times you have multiple sectors within an individual company deploying individual projects, oftentimes completely independent of each other.
There's a lot of investigation going on. They're evaluating why they should do this, what is truly going to be an ROI that they're going to get out. The dollar amount that it takes to implement is so wide, right? Some people are predicting low numbers and high numbers, and the CFO is sitting there going, I'm not buying into that.
Not only are deployments moving slower than expected, but connectivity doesn't find universal acceptance in all markets.
Specific verticals have different use cases, and a lot of them are simpler to prove. Field asset tracking, trucks, products, assets that are out there. That's a solid vertical. You got the ROI, it's sellable, but healthcare, when you look at healthcare, very difficult. Where are you going to sell it? Are you going to sell it into a hospital? Are you going to sell it to my 82-year-old mother? Who's going to pay for it? Is it an insurance scenario? So it becomes a little bit more difficult in certain verticals.
Clearly, complexity slows down adoption. But there are bigger issues that need to be resolved before it can reach critical mass. Issues like communication across devices and industries.
The Internet of Things is defined by the fact that it's not defined. And what that means is that the verticals, the market segments that are entering into IoT, that are considering to be part of IoT, that it is so vast, it is so spread, that there's not such thing as one standard for it.
The fragmented ecosystem really is one of the gatekeepers that slows down the adoptions of standards or how we're going to move forward to improve service levels within an industry. Healthcare has so much promise in our environment today, but it's been very slow to adopt standards on how payers, providers, and patients are going to work together to subscribe, deploy, manage, and pay for remote healthcare management solutions.
We've certainly seen lots of IoT solutions come to market very quickly without any interoperability with anything outside of the manufacturer's own control. But we've also seen lots of systems come to market very quickly without meaningful or adequate security. Not all, but most devices coming to market are almost completely absent of security. The vast majority of cars are far more hackable than most people would realize.
If you kind of broaden your definition of the IoT to say it's not just connected devices, but it's connected cars, it's aircraft, it's connected drug delivery systems, all of those things are really at risk from a security vulnerability perspective. So if those things are attacked, it could be life and death. So that's why I call it the Internet of Broken Things. It needs to be fixed.
Security is an architecture. It's not something that you can put a band-aid on it in different parts of the network and solve it.
If you look at the whole service delivery chain, from the silicon on device to the operating system on that device to the SIM card in the case of cellular, go all the way back through the access layer into the network over to the cloud and the data center, Each one of those elements has its own level of security. So the question is not, is each component secure, it's what about this end-to-end solution? At the level of marketing, we've had so many historic breaches, whether it's Target or the recent hacking of Chrysler cars, for example. As an industry, the IoT industry has regularly been fairly lucky in this context, in that we still don't have this mass of devices that's so ubiquitous that it's an easy target, but it's getting there.
You would think putting your connected device on an existing network would be an easy choice. Not so.
There's not one single kind of network that will meet the needs of all kinds of devices, because not all kinds of devices are equal.
You've got companies trying to decide, do we make an investment at this point in time in 3G, do we even look back at 2G, or look forward to LTE?
Does it need to be mobile? Does it need to be high speed? Does it need to be low latency? How much data comes through and in what fashion?
And when you consider carriers have aggressive plans to reuse the spectrum from their aging networks for next-generation networks, picking a network doesn't get any easier.
Basically, they don't want to make a significant investment in technology, get started, get a product out the door, get an deployment of up to 100, 200,000 devices, only to find out that they've invested in a technology that's no longer going to be supported.
So a lot of the cellular network deployments were made on GSM primarily because they were very inexpensive modules. You don't usually use a tremendous amount of data in M2M type applications, so that module's perfect. That costs about $5 to $10 in today's range. So when you start to look at shifting the entire network off, that means that whatever they have in the field, unless it's a multi-mode device, is going to have to be replaced with a new module.
With speed optimized networks, particularly 3G and 4G, they do a great job at providing high bandwidth data. But there's a cost to that. The focus on high speed necessarily means that your power consumption is going to go up, and that means shorter battery lives. Now, for smartphones, people are fine with that. But if you're talking about a battery-powered IoT device, a sensor in a farmer's field, for example, there's no way that the farmer can afford to go out to that field every day to change the batteries, or even every week or every month. It's got to last for years.
It's very hard to predict today what the data patterns are going to be for a smart city, for example, in 20 years. But that's the network they're trying to design today, is something that's going to be able to address those needs.
The sheer number of connections we could get in the IoT is huge, because it's not limited to one connection per person. You could easily have 10 connections per person. Your car, your smart meters, consumer electronics devices, white goods, they could all be connected.
When you start talking about billions of sensors, even though the individual bandwidth or the number of bits per second is pretty low, the fact that they keep hitting the network, keeping the sessions open, keeping that signaling plane open of where they are, establishing the connection and whatnot, you quickly then exhaust the signaling plane, even though from a data perspective, it's quite small in aggregate.
It doesn't matter which industry, whether it is in manufacturing or healthcare or consumer products, every industry is getting redefined because of what it can do to your business.
A lot of predictions out there about the size of this market. Some of them saying that as many as 20 billion devices connected to the network by 2025. If we're going to do that, there's a few things that we have to keep in mind. Number one, it has to be low touch and it has to be self-service.
People don't want to go deal with multiple companies and multiple technologies and string it together. They just want an encapsulated solution that it's easy to connect, it's easy to get the data and visualize it, and it's easy to automate it.
Companies have vehicles, companies have assets, companies have machines. Why do I need 3 different complete solution stacks for those 3 different use cases? If I can manage it with one interface, with one set of building blocks, with one set of infrastructure costs on a horizontal platform, and I can share information easily between my vehicle data and my asset data and my remote energy management data, maybe as an enterprise, I can create some better solutions.
If ROI is a key motivator for IoT deployment, few use cases show a more direct ROI than the so-called industrial IoT sector.
So looking at industrial, if you look at things like discrete and process automation, there's a tremendous interest in knowing how can I make this process run more efficiently. And the key to that is really measuring things more effectively.
We went to Detroit, we spent a lot of time out there, and we realized that one of the biggest issues is that you've got a long assembly line, you have a lot of robots, one of them goes down, it brings the entire assembly line down. Every minute of downtime in a factory costs them between $16,000 to $20,000 every minute. And it usually takes about 4 to 5 hours to fix it and bring the rest of the factory up.
Being able to do things like predictive maintenance, knowing when a machine is going to fail before it's going to fail, because you know that it's running hot, there's more vibration, the noise is a little bit louder because we've got sensors, pervasive sensing all over this.
By connecting the robots and detecting when things are going to go wrong, fixing it before it happens, and avoiding these sorts of incidents, then we're able to put very clear business propositions together and convince the factory operators that, hey, you go invest this much through technology, you're going to avoid this much cost.
We're really glad to see the information technology, IT community, and the operational technology, OT community of so many companies coming together to leverage from the IT side compute horsepower that a decade ago was practically unimaginable to most people. But yet on the OT side, the operational environments are very demanding. Assumptions can be very dangerous things in that kind of an environment.
Well, if you think about a production line where you have pieces of heavy industrial equipment and you have factory workers mixing in the same space, safety is actually one of the top concerns. Any lag in signal can have significant consequences, not only for the production line, but for the safety of the workers. For an IT guy, an environment of 9 nines uptime, that's pretty good. They're feeling good about themselves and they're patting themselves on the back. For the OT guys, if they're not hitting 100%, somebody could lose a hand or an arm. So there are significant consequences, and they have technology that's been in place for decades, but the reason it's been in place for decades is because it's pretty bulletproof. So displacing that is not done lightly for them.
So I think success is going to require a lot of active communication, a lot of patience with each other, because these two communities come from such different worlds, and mutual respect. And where we see those 3 ingredients together, we see companies make tremendous progress very quickly to really reap the rewards of IoT.
We collect temperature information and the time of arrival of a truck to a delivery point for food in transit in the cold chain. And our customers receive the food information, the temperature information, and they say, wow, this is a great load, it was handled really well, everything's wonderful. But what they're not actually looking at is the time of arrival. We've done some analysis and we can help our customer manage their arrival load to match their labor load to help improve their processes. Because we can tell at which doors are used at what time, and we can help them redesign their business processes to make their business more efficient and effective and make their lives easier.
Many fear regulatory interference or overreaction to high-profile security breaches pose a significant threat to IoT. While that risk is real, what's also real is that regulations can be a positive force for the Internet of Things.
Very large projects in the IoT world are initiated by regulatory requirements.
In the industries where we've seen the most rapid adoption, we've seen them very quickly getting to what are the standards, and we've seen the government regulations very often come in and help them do that.
As an example, meter reading, electricity, gas, water meter reading are imposed by regulatory requirements of different governments.
It can bring the right ecosystem together, and it can also incent them to take some risk in the short term to help them get to those standards much quicker, rather than just waiting for those standards to evolve by themselves.
As the industry pushes forward, one thing becomes clear. The predicted avalanche of devices and use cases will necessitate a change in the way we think about data and how to manage it.
One of the biggest issues is that once you connect things, there's so much data being generated that you can't possibly bring it all back to the cloud and process it.
Even if you have thousands of cameras, not all cameras are interesting. Most of the cameras don't have anything meaningful that's happening in front of it. So how do you quickly recognize which cameras are interesting so so that you can devote your computational resources, your networking resources, and even your human cognitive resources towards analyzing what's going on in the environment.
Is it more important to put maybe a little bit more processing capability in the device at the edge of the network, let that do some amount of analysis on its own, and then report exceptions rather than reporting a steady stream of, yep, things are good, yep, things are good, yep, things are good?
If you look at one of these self-driving cars, with the lidar on top of the car, that's generating about 4 terabytes of data per minute. So there's no way to bring that in. And we are building compute and storage capability inside our networking gear that not only we connect things, we can also bring the brains that analyzes the data right to the edge at the sensor level. So you start looking for things that are important. And we believe that more than 60% of the data in the future will be processed at the edge, not in the cloud.
Another shift in business as usual will come from security.
It's really important for these devices coming to market to have security built in. A lot of these devices, once they're released by the manufacturer, nobody's free to modify them. You're not allowed to modify the thermostat that's on the wall. You're not allowed to modify the industrial robot that you've just put on the assembly line. There are both technical countermeasures against those modifications, and there are also legal restrictions through warranty clauses and things like that. So for those reasons, those devices really have to have security built in from the beginning. And that's a new concept to a lot of people that used to build a system or a service or a machine and allow security to be added later by slipping a disk into it.
I think the trend is very much towards the level of embedding security everywhere. We have to embed it in the chips, we have to embed it in the network, we have to embed it in the data and in the processing. So it is absolutely end-to-end.
Show them an application that has a lot of value and saying that, hey, you are not benefiting from this application because you don't have a secure network. So in order to take advantage of that, solve your security problem at the same time that you can start deploying this application, that you can remotely manage and monitor your network. So instead of turning it into a glass half empty issue, go spend a lot of money just for the sake of security, we're trying to tie it into a compelling application that here's where you're going to get value and solve your security problem at the same time.
Perhaps the only new technology with more unanswered questions than IoT is 5G. And when you consider how important it will be for the two to work well together, it makes you realize how important the development work of 5G will be on IoT.
5G is an open question at this point for a variety of reasons. One is we're still early, extremely early in the standards process.
There's about 8 different specs that are floating around right now. Some of them address different pieces of IoT, but it's really too soon to say which one is going to be if it will be a magic bullet, if you will, for solving all of IoT's ills.
The early stage of cellular networks that will be contemplated in the 5G umbrella are Release 13 modules.
Release 13 is an evolution of cellular technology. You have to understand that everything that was put in place today developed for the concept of more, faster bandwidth, more services, smartphones. IoT is a different animal. We want to create something that can serve needs dedicated to supporting all these wonderful applications we're talking about. Things that can be battery powered, things that can be left in the field for long amounts of time, things that don't really require a lot of maintenance, and most importantly, can affect the cost. So Release 13 really has focused on the needs of IoT type devices.
Clearly, Release 13 addresses the low power and low bandwidth capabilities, but then when you get into the higher bandwidth capabilities, you also have needs for full LTE spectrum. And then there's other domains for low power wide area technologies such as LoRa, such as Sigfox, where you're building large scale network infrastructures to address smart city solutions and things of that nature. An IoT solution will use not only one of these technologies, many times we'll use 2 and 3 of them.
If 50 billion devices do make their way out into the world, what will happen to all the data that's created? Is it trash or is it treasure?
You can collect a tremendous amount of data off of the sensors, but getting data off the sensors in and of itself isn't enough. It's really what you do with the data and how you analyze it that really starts to provide value for your business. That's where you can really start to drive intelligence that's going to help you make better decisions for your business.
If you stand back and take a look at what machine-to-machine and IoT really provides, it's a means to an end. Software and systems, components, and devices communicating with each other are nothing new. We've been doing that for many years. But now, the scale that we're able to do the communications at the cost point that we're able to successfully do that, is really redefining what we do in terms of communications and data collection. The real value statement or the payoff is the analytics at the back end. To be able to cross-correlate that data and then to be able to make decisions and cross-correlate analytics based upon that is really the value statement that we're all working to achieve. IoT is that means to an end, but it's a critical means.
Business sits at a crossroad when it comes to IoT. It can drown under the weight of technology run amok, or seize one of the single greatest business opportunities in decades. So, which will it be?
I think at some point in time we're going to stop talking about the Internet of Things, to be perfectly honest. I think that this is important for us to talk about right now. I think at some point in time we're going to stop talking about that, because I think that what we're talking about is we're talking about the spread of connectivity and computational power, and at some point in time it's going to be like electricity.
For the Internet of Things to be most effective, it is going to be unnoticed. IoT will grow to be something that people overlook. It's like a service industry. Service industry is the toughest industry out there because when you're doing a great job, nobody notices.
I do believe that you're going to see the ecosystem get more mature. I think you're going to hear the selling community and the buying community start speaking a more common language, which is the gap today. So I think it's going to just mature to the point where it's easier to buy, easier to sell, easier to support.
At the end of the day is how do you come up with an architecture, right, that brings the cost of connectivity like from $20 per year to $1 per year, right? And also make it pervasive so you can have high volume, right, and make it very secure.
Those who don't make the transition to that digital world will be out of business. Their competition will be so much more connected to the customers. They will be so much more efficient, and they will be compliant with regulatory elements that will put them miles ahead of their competition. So this is not only a nice to have, it's a must.
IoT will go where the ROI can be made. Initially it's about this is cool. But cool doesn't pay for 20,000 units to be installed with hardware and have the whole value chain make money off it. That only happens when at the end somebody pays money because it makes them money. And I believe that the driver is going to be the enterprise world. Business to business, or where enterprise will meet the consumer. But it is the enterprise world that will drive it.
Nothing is changing history here. You're going to have to take advantage of the best tools that you have at the time to solve the problem. You know the old saying, knowledge is power. Actually, knowledge is profit. And if you don't take advantage of this, you're going to be left behind.
Stay tuned for Part 8 of the Network of the Future documentary series, Navigating the Path to 5G, coming soon to TIANow.org.